Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Welcome to episode 5 of the product rule series. Today we're going to be doing another question, and this question is going to be quite different from the ones you've been seeing. It's quite simple as well, but it's something to definitely expose you and help you further, especially when you get different questions by your professors in your assignments. So we have f of x equals 8x cubed e to the 5x. So what this is trying to tell you is basically what I've explained. Whenever you have we use the product tool whenever we have two subfunctions. 8x cubed is a function by itself, and then e to the 5x is also a function by itself. So you have two subfunctions that are multiplied together. And in order for us to be able to solve a question like this, we have to apply what the product rule we have to understand what the product rule is, and we have to apply what the product rule says. So the product rule says, like I've explained before in the first 4 episodes, you have y of x equals f of x multiplied by g of x. So this is basically a statement of a function. Then when we apply the product rule, and this is good that I'm actually repeating it on the 5th video, because it basically is just going to be good for your brain when you keep seeing the steps repeated over and over again. You're going to be able to almost memorize it and be able to solve problems as you go. So you have, and I hope like you students, or basically when you watch maybe the first 3-4 videos from like the 5th video of any series that I make, I think you'll be able to understand a good detailed explanation, and you'll be able to solve like the more videos in the series without much help. So I advise you that anytime you see a question that I put, maybe you should start by doing the first half of the question and then play the video to see basically my thought process. But I'm going to advise you to do that after you've watched maybe like the first 3 episodes of any of the videos that I make, because I try to go in detail as much as possible. So now this is what the function looks like with the blue arrow. This is what it looks like after we apply the product rule. We're going to have something that looks like this. Y of x, right, equals f of x multiplied by g of x. And what did I say? We're going to differentiate it, because to apply the product rule, you need to differentiate the function. And this is just basically a general function. So then you have y prime of x, which is a way for you to say something is differentiated, equals f prime of x. So derivative of the first subfunction, this is the first subfunction, so first one, and then this is the second subfunction. So basically, you have the derivative of the first subfunction multiplied by the second subfunction that has not been differentiated or derived, plus the derivative of the second function, g prime of x, multiplied by the derivative of the multiplied by the first function that has not been derived. So just f of x. So basically here, let me use a red pen. So you have this is differentiated, right? This one is not differentiated. And then this one is differentiated. And this one is not differentiated. And if you remember from the first video that I made, I kind of explained something to you guys that this is just how it's done, right? But you can actually switch the positions in product rule. But generally, in mathematics, many professors do not switch the positions because obviously since it's multiplication, right, and multiplication, that's where you get the word product from. When something is multiplied, it's like saying, oh, how do you 5 multiplied by 3, what does that give you? That's 15. 3 multiplied by 5, what does that give you? That's also 15. So what I'm saying is that you can also have this written as y of x equals g of x multiplied by f of x, right? Or you even have, or you just have f of x, like you have what is at the top here. You have f of x multiplied by g of x, but instead you derive the second function and have g prime of x multiplied by f of x plus f of prime of x multiplied by g of x. What I'm trying to say here is it doesn't matter the position in product rule, but when you go into the next part of this series, which is quotient rule, you're going to see that the position really matters. So the only reason why, if you see your professors sticking to this first one that I am boxing here in red, that I'm putting in a very weird looking box in red, the only reason why professors kind of stick to this is just so that there is some level of consistency in mathematics. Students already find calculus or different areas of mathematics difficult. If they start saying, oh, you can switch it all up any way you want, and this is calculus, it can become confusing. But it's the same exact thing. It's like saying 5 times 3 is equals to 15, the same thing as 3 times 5 equals to 15, or 2 times 4 plus 4 times 9 is the same thing as saying 4 times 9 plus 2 times 4. It doesn't really matter. But yeah, that's just my point. So if you're either in an exam hall and you mistakenly switch the positions and you're gonna get the same answer, so far you do the differentiation process correctly. So yeah, that's just one thing I wanted to mention. But yeah, let's go to the actual solution. Let me rub all of this off. Hopefully this is something you understand, and you can try it on your own. You can just switch it, but you should have like understood this to an extent before you start doing some of those questions, in a way for you to see that there is not a big deal. I'm telling you this so you can get some level of comfort when doing calculus, right? So that's it. Now let's go to the next page. For this next page, let's go back to the question. We have a big F of x equals 8x cubed. Apologize for that. 8x cubed multiplied by e to the 5x. So multiplied by e to the 5x. So what do? We already know what the product rule looks like, so we're gonna write that out. So we have the general is basically the function, so I can say y of x or f of x, it doesn't really matter. Let me just use f of x here. F of x, big F of x, so capital F of x. Repeat what was written here. Say f of x, not just f of x prime, or f prime of x. F prime of x equals, now this is a differentiated information, small f prime of x multiplied by g of x, right? That's what we're trying to do. So the derivative of the first function multiplied by the underived second function multiplied by the derivative of the second function, so g prime of x multiplied by the underived first function. Yay! So this is really what we're doing here. Let me put all of this in bracket. Okay, so now this is basically the underived one. Now the first thing I will advise you to do, like the way I've been explaining in the previous videos, is for you to put the position. So this is the first subfunction, right? First subfunction is this one, so I'll put first, and the second subfunction is this one. So all you have to do is just input them in the different positions. So you have f prime of x, right, equals the derivative of the first function, so that is 8x cubed prime, which is being what you're trying to say, derivative of the first function, which is 8x cubed, multiplied by just the second function alone without being derived. So that's going to just be e to the 5x plus, what is g prime of x? G prime of x is basically e to the 5x, right? Multiplied by the first function underived. So that would just be 8x cubed. So now this is one way to do it. One way to do it is for us to find a corner in our notes and do the derivative and then input the answers in here. Or we can just do the direct method, which is my favorite method, which is just for us to just do the derivative straightforward. So now we have 8x cubed differentiated. Let me use the color yellow. So that's saying 8 here, x cubed. X cubed here, when we want to derive x cubed, we're just going to go back to what we've done previously, which is the power rule. If you haven't watched the power rule from my channel, please go watch the power rule. It's it's going to be really helpful for you to understand. Or if you're already doing product rule, then you're supposed to have some understanding of how the power rule works. So basically, I'm just going to drop the 3 down here. So you're going to drop the power of you're going to drop the power or the exponent of the variable down. So that's going to be 3. Okay, I dropped it down in front of x. And then I'm going to decrease the power of the variable. In this case, the power is x. Sorry, the power is 3. We're going to decrease the power of the variable by 1. So 3 minus 1 is 2. So the area of x cubed is just 3x squared. Then the multiplied by the second subfunction that is underived just by itself, and that's just multiplied by e to the 5. Sorry, just multiplied by e to the 5x because we're underived. We're just basically dropping it down, you know. Just like we dropped the 8 down here, we're going to drop this one down because we're not really deriving anything in this case. Plus e to the 5x. So guess what, you guys? That's why you always have to check your work. I forgot to put prime here. You guys can see I'm shading a prime on this one. So if you mistakenly have that wrong in your notes, please correct it. Plus the derivative of the first function plus the derivative of the second function, and in this case the second function is e to the 5x. So whenever you do exponential functions, basically if you look at my videos where I do power rule, just after that series you can also find the derivative of exponential functions. So in this case you have e to the 5x, and derivative of exponential functions just involves you just putting the exact exponential function that you're supposed to derive. You're just going to bring it down, right? Just bring it down. So we just brought this whole thing down. But that's not all. Then you have to do the derivative of whatever the power of the exponential function is. And what is the power of e? The power of e is 5x. So multiplied by the derivative of 5x. So we're going to do 5x prime. So basically, let's look at a corner here. Please look at the corner box that I have in color yellow. The derivative of e to the 2x is the same thing as saying e to the 2x multiplied by the power of e. In this case, the power of e is what? The power of e is 2x multiplied by derivative of that, and that's just going to be 2x prime. What is 2x prime? That is saying that derivative of 2x, that's just the answer becomes e to the x multiplied by 2, because so you end up with 2 e to the 2x. And if you're wondering that, oh my god, why is it that anytime we do the derivative of e to the x, we always just get e to the x back? Is because what we're doing is, let me show it to you. Basically, this will help you. But I advise you to struggle with derivative of exponential functions, just watch my video on it or any other good videos you see online. So you have e to the x, so that's just going to derivative of e to the x is the same thing as repeating what was given to you. So e to the x multiplied by derivative of the power. And what is the derivative of 1x, or what is the derivative of x? Remember, whenever x stands by itself, its coefficient is 1. So what is the derivative of x by itself? We know that derivative of variables, any variable, is just 1, right? So the derivative of x is just 1. Derivative of s as a variable is 1. Derivative of t as a variable is just 1. So that's why anytime they tell you to do the derivative, so it's just like saying 1 times e to the x. Then you'll be wondering, oh, the derivative of e to the x is always e to the x. That's because the exponent is just x, and when you derive x, you get 1. So that's just a side note or a side box to help you understand what's going on here. And I'm sure you guys can already guess what the derivative of 5x is, or what is the derivative of e to the 5x. You already know it, but we're gonna get there. So multiply all of this here by you just dropping down the first function that is underived. Remember, we're not deriving the first function, so that will be multiplied by 8x cubed. So now what you have is, let's just use red now. So you have f prime of x. What is 8 times 3 here? What you have is 24. And then we just have x cubed here. So we're just going to do 24x. Sorry, we just have x squared here. So we just have 24x squared multiplied by e to the 5x, right? Plus e to the 5x here multiplied by 5x prime. So 5x, or in bracket 5x prime, the derivative of 5x is just 5. And then multiplied by 8x cubed, right? So that is really it. And so f prime of x equals 24 e to the 5x, right? X squared plus 5 times 8 is what? Is 40. So you have plus 40, and then e to the 5x, right? X cubed. So this is basically what this is. This is the answer right here. The entire work we've been doing so far is just basically this one. And guess what? Sometimes you may have a professor, let me rewrite the answer again. You may have a professor that would prefer you do something different, right? He would prefer, let's rewrite the answer. So f prime of x becomes, you can see how simple it is. I try my possible best to break things down so nobody is under stress. 24 e to the 5x x squared plus 40 e to the 5x multiplied by x cubed. If you have some teachers that want you to always factor out your answer, you just have to look for the common factor in this entire question. And what is the common factor? Well, we have e to the 5x can be brought out. We have x squared can be factored out as well. So it's going to cause this from x squared. If you bring out x squared from x cubed, you'll be left with x. And then you can bring out e to the 5x. And then what is the common factor between, or the highest common factor between 24 and 40? Well, if we bring out 2 is not going to be the common factor, because if we bring out 2 from 24, we get 12, right? We get 12. If we bring out 2 from 40, we get 20. But there is also another common factor between 12 and 20, and that's 2. So if we bring out 2 again, we have 6 here, and we have 10 here, right? So that's not another highest common factor. We can bring out another 2 again. So you have 3 and you have 5. So the highest common factor in this case would be 2 times. So there's a 2 that we brought out right here. So that would be 2 times 2 is 4, 4 times 2 is 8. So the highest common factor will be So let me erase all of this basically and write the answer. So this is whenever you have a professor that asks you to, or if you're just one of those people who like your work to be neat so that you can see everything, especially if you're expected to do more with this, right? If you're expected to differentiate further, or if you're expected to differentiate further, or if you're expected to do more with this, maybe in a differential equation class, then you might actually like it. So what you end up with is 8. Bring out 8 from this, 8e to the 5x. Then remember, we're going to bring out x squared, right? And then put this in bracket. If we can bring e to the 5x and x squared, we know that 8 times 3 is 24 because we brought it out 3 times. Yeah, well, 8 times 3 is 24. Just know that. Plus, if we can bring out 8 from 40, we have 5 left because 8 times 5 is 40. Just like 8 times 3 is 24. And we brought out e to the 5x, so nothing is going to be here. We brought out x squared, so we just have x. So basically, this is your answer. F prime of x can also equal this. This is the factored one. Factored answer. And this one here is the unfactored answer. Yay! So this is the end of the video. I wish you guys all the very best. Hopefully this is helpful to a whole bunch of you guys. And if you like this video, please subscribe. Make sure you leave a comment section. If you have a question, please email me your question. I'm going to try and get to your question. Please follow my social media platforms. And the main one is on Instagram. I post on there relating to math, chemistry, and basically STEM. So I would advise you to please watch the videos, learn as much as you can, and if you have any questions, email me. And by the way, I'm also looking for somebody who is really good with video editing. I would like a real good video editor. So if you're a really good one, or you know somebody that is a good video editor, please email me as well, because I would like for my videos to be coming out more and more and for them to look better. But I actually do not have enough time to do that as well. If not, I'm going to be posting a whole lot less. So I wish you guys all the best. Take care of yourself. Assalamu alaikum wa rahmatullahi wa barakatuh. May Allah subhanahu wa ta'ala be all of you. Ameen ya Rabb. Assalamu alaikum.